In the city of Alexandria, during the 1st century, the air was often heavy with the scent of salt from the Mediterranean and the industrious hum of a center of learning. Within the hallowed grounds of a temple, a crowd would gather, their eyes fixed upon the great bronze doors that guarded the inner sanctum. A priest would step forward, igniting a fire upon a pedestal-like altar that sat before the entrance. For many minutes, nothing would happen except the steady rise of smoke and the crackling of the cedar wood. Then, without a single human hand touching the metal, the massive doors would begin to pivot with a slow, grinding dignity. To the uninitiated, this was the invisible hand of a god responding to the sacrificial flame. However, beneath the stone paving stones and behind the thick masonry, a sophisticated network of physics was at work. This was the mechanical genius of Heron of Alexandria, a man whose understanding of pneumatics and hydraulics preceded modern engineering by nearly 2 millennia. The logic begins with the altar itself, which was not a solid block of stone, but a hollow vessel. As the fire burned atop the altar, the heat was conducted through the metal or stone top into the air trapped within the chamber below. We must consider the nature of air molecules as they absorb thermal energy, increasing their kinetic motion and pushing against the boundaries of their container. This trapped air, seeking a way to expand, was funneled through a concealed pipe that led deep underground to a secondary chamber. In this lower chamber sat a large, spherical vessel made of hammered bronze, partially filled with water. The increasing air pressure from the altar was directed into the top of this sphere, pressing down upon the surface of the water with consistent force. Within the sphere, a siphon reached down toward the bottom, providing the only exit for the pressurized liquid. As the pressure from the heated air grew, it forced the water up through the siphon and into a large, heavy bucket. This bucket was suspended by a system of ropes that were intricately wound around 2 vertical cylinders, which served as the axles for the temple doors. The mechanical choreography relied on the slow, steady accumulation of mass within the hanging bucket. As the water trickled in, the bucket became heavier, eventually reaching a point where its weight surpassed the static friction of the door hinges. Gravity began to pull the bucket downward, and as it descended, the ropes unwound from the cylinders, causing the doors to rotate on their pivots. The speed of the opening was controlled by the rate of the fire's heat and the diameter of the siphon, ensuring a smooth and awe-inspiring motion. Every component was designed with precise tolerances, from the hemp fibers of the ropes to the lead weight used as a counterpoise. On the opposite side of the rope system, a counterweight was carefully calibrated to pull the doors closed again once the fire was extinguished. When the fire died down, the air in the altar chamber began to cool, creating a partial vacuum as the molecules slowed their motion. This vacuum acted as a restorative force, sucking the water back from the bucket, through the siphon, and into the original spherical reservoir. As the bucket lightened, the counterweight became the dominant force in the system, pulling the ropes in the opposite direction. The doors would then slowly swing shut, returning the temple to its silent, sealed state. This entire process occurred in near silence, hidden from the eyes of the public, who saw only the result of the thermal transition. Heron's design was a masterpiece of hidden logic, utilizing the fundamental laws of thermodynamics long before they were formally codified. The materials used were as important as the design itself, involving the use of cast bronze for the airtight seals and seasoned wood for the structural supports. The water served as a medium of energy transfer, a fluid battery that stored the potential energy generated by the heat of the fire. The ropes were often treated with oil to reduce friction and prevent the snapping of fibers under the heavy load of the doors. We find in Heron's writings a deep fascination with the way nature could be mimicked and manipulated through geometry and craft. The scale of these doors was often immense, weighing several tons, yet they responded to the subtle expansion of air with the grace of a living thing. The mathematical precision required to balance the counterweight against the friction of the stone sockets is staggering. One must imagine the engineers testing the system, adjusting the volume of water and the length of the ropes until the timing was perfect. The air within the system was a closed loop, a lung that breathed in the heat and exhaled the motion required to reveal the divine. This mechanical logic removed the need for manual labor and replaced it with a predictable, repeatable cycle of physics. It is a reminder that the boundary between magic and technology is often defined by what is hidden from view. The ancient Greeks understood that the elements, earth, air, fire, and water, could be harnessed to create experiences of profound wonder. As the water moved through the lead pipes, it followed the path of least resistance, dictated by the pressure gradients created by the fire. The cylinders around which the ropes were coiled had to be perfectly vertical to ensure the doors did not lean or bind. The pivots at the top and bottom of the doors were often set into bronze cups, lubricated with animal fat to ensure a smooth rotation. Every detail was a testament to a culture that valued the intersection of art, religion, and scientific inquiry. In the stillness of the temple, the only sound might have been the faint trickling of water or the low moan of the heavy metal pivots. These sounds were easily masked by the chanting of priests or the rustle of the wind through the colonnades. The complexity of the system was such that it required regular maintenance, ensuring that the airtight seals remained intact and the ropes did not fray. The legacy of Heron of Alexandria is not just in the machines he built, but in the way he thought about the world as a series of interconnected systems. He saw the potential for automation in every aspect of life, from the way we draw water to the way we honor the gods. The self-opening doors were perhaps his most theatrical achievement, a synthesis of all his knowledge of fluids and forces. Today, we see the descendants of these systems in every automated entryway we pass through, though we use sensors and electricity instead of fire and siphons. The fundamental logic, however, remains the same: the use of a trigger to initiate a mechanical sequence. In the cooling air of the evening, the temple would stand silent once more, its secrets buried beneath the floor. The stones, warmed by the sun and the altar fire, would slowly release their heat into the night air. The water in the reservoir would settle, awaiting the next sacrifice to begin its journey through the pipes. The mechanics of the divine were, in the end, the mechanics of the physical world, applied with extraordinary foresight. As we contemplate the ingenuity of the past, we find a sense of peace in the orderly movement of the universe. The laws of physics are constant, providing a foundation upon which all our innovations are built. In the rhythmic cycle of expansion and contraction, we find a natural pace that invites a quiet reflection. The ancient world was not just a place of myth, but a place of rigorous observation and clever application. As the mind follows the path of the water through the siphon, the complexities of the modern world seem to fade away. We are left with the simple beauty of a weight descending and a door opening, a silent testament to the power of human thought. The fire may have long since gone out, but the logic of the mechanism remains as clear as ever. Discover more history by watching the next video. We're eager to share more with you. You can't go wrong. All our videos are deeply detailed, dull while fascinating, and distinctly sleep-inducing.